Right. Assalamualaikum warahmatullahi taala wabarakatuh. So today I'm going to give a lecture. I try to make as fast as possible, as short as possible for this topic, which is topic of vector algebra. Actually, this topic has been covered during your Tamidi and secondary school, form 5, I think so, or matriculation level. So hopefully this topic is not it is just become a refresher for you. It's not become a new burden for as a new subtopic or content to be learned. Okay, so before we start together, we recite a dua. Bismillahirrahmanirrahim. Allahumma aftah alayna hikmataka wa anshur alayna min khazaini rahmatika ya arhamar rahimin. Rabbi shrah lana sudurana wa yassir lana umurana wa hlul 'uqdatam min alsinatina yafqahu aqwalana bizidna ilman nafi'an zidna fahman nafi'an. Bismillah tawakkalna 'ala Allah la hawla wa la quwwata illa billahil 'aliyyil azim. Okay, so for vector algebra, so what is vector? So basically, vector algebra is about the vectors and its manipulation. Um, it's should be in space vector, which is normally, as we know, the vector in Cartesian coordinate of x and y, x and y, or maybe in a b ij component. So we will learn the description and algebra vector, how vector may use to describe lines and planes. What else? And also practical use vector in finding distance. I mean, those things, all of these things is quite familiar for you, especially for those who already learn in secondary school or form 4 and form 5, and maybe during your tamidi. The simplest way to describe a physical quantity that it can be specified as magnitude and direction. As a magnitude is it is scalar quantity. Scalar is called a value only. It's not related to any direction. For example, you have a temperature, you have a time, what else? Density. So all of these things doesn't require any direction. So that should be a bit familiar for you. It's quite straightforward. A vector is requires both a magnitude and the direction in space. But for vectors, you have a scalar. I mean, you have a value, and also you have a direction. So you know the direction of your of your particular value. So for example, 3 meter per second. So you know that is 3 meter per second is a vector quantity. You should know which direction, on right direction or left direction or whatever. All right. So a vector. A vectors of a large number of vector can be used to describe a physical world, including velocity, displacement, momentum, and electric field. Vectors are also described a quantity such as angular momentum and surface element. Area and the area direction defined by a normal and its tangent for sure. So such their definition may seem somewhat arbitrary through the fact they are standard and not physically intuitive for vectors such as a force. So vector denoted by a bold type, the convention of many books or by underlining. So either the the style is bold, or you have a underlining. What kind of that? What type of that? Some of written, the later used in handwritten work. So maybe you have, for example, A, something like that. So you have bold A. So that is kind of the way to write. You have a cap there, and also, yeah, there's a lot of way to write vectors, but should be the familiar one will be this kind of type, and also bold one. addition of two vectors showing that. So this is a standard one. So you have A and B, A and B there. But the vector of the, when you add up the vector will take place in here, which is the resultant of the A plus B. There is no distinction between an arrowhead at the end of the line and one along the line snag, but rather use which give the clear diagram. Vector in a diagram as a line together with arrowhead. So you have the direction of the arrowhead as your vector direction. Resultant vector of two displacement vector are displacement vector that result from perform first one and then another displacement. In previous one, the process known as a additional vector, so vector adding the value. So the criteria of the philosophy of additional vector, you have a commutative signature. So you have A plus B equals to B plus A. It goes the same way. Either you A plus B, which is this one, or you go B plus A, B first and then A. Both give you the same resultant vector. So that is means by commutative. The generalization of this procedure to the addition of three or more vectors is clear and leads to associativity property of addition. So either you add B plus C first and then plus with A, or you add A, you start with A plus B and then you plus with C, will give you definitely the same thing. For example, in this example, so this is our A plus B. So this is the vector A plus B. A plus B can be first plus, do it first and then you plus with C. And then it will give us definitely the same as A plus B plus C first. So we have B plus C for this part, and then we go into plus A. I mean, we go to another operation. So definitely this thing are same. This thing, I will make it color another one. Okay, sorry. This vector A plus B first and then plus C will definitely same as A plus B, B plus C first and then plus with A. So this is commutative associative condition. What happened to the subtraction? Is it give the same way? Actually, it is again similar one. I mean, you can add, you can minus A minus B, and also A plus the negative B. So you have subtraction of two equal vector yields to 0. So this is not A is not equals to B. So that is the main condition. If the A equals to B, so then you will get definitely 0, right? So this is the case. Not equal vector. Multiplication, it is a scalar multiplication. Some value added to the vector field, so the vector field becomes longer. So this is the a similar and normal activities or normal scenario for algebra, for especially those algebra multiply with a lambda, I mean a constant value. Multiplication of vector by a scalar, not to be confused with a scalar product. It's not a scalar product. So the product, you know, A dot B, right? So this is multiplication by a scalar. It is a lambda A. It is a working vector multiply with a constant value. Give a vector in the same direction but not in original magnitude. Either you multiply with 1 over 4 with A, will give you half of it. I mean, it's become 1 over 4A. The vector might be shorter quarter from the original. So this is the 1 over 4A vector, right? I'm pretty sure you can understand, but it is just for memorizing and refreshing again. So this is commutative associative scalars by lambda and mu. It is quite straightforward. Okay, so let's go into the example. Illustration of the ratio theorem. The point P divides the segment of AB from E to B with the ratio lambda and mu. If the position vector of the point A and B are A and B, so this is a position vector A and B from the origin. So you have B vector that point into point B. You have A vector that point into A vector, A point, sorry, vector A point to A point A. If find the position vector of the point P, so what will be the position vector of P? So it is right. So the solution is quite simple. OP equals to, from O to P, which is a vector P, right? It's a vector P. I just bold it. I just circle it. So vector P is A, vector A, plus the ratio of lambda over lambda plus mu. Ratio of lambda plus mu of the all together multiply with AB, which is, what is the vector AB? Vector AB is vector A minus B, vector B minus A. It's okay. If we go straight forward to the solution given here, my vector B minus vector A. So B is in upward direction, but for A, in order to get AB vector, so you have to do, let's say, the vector AB like this. So A cannot be in this direction. That should be negative A in another direction. The opposite one. Right? This is negative A. So this is the ratio that gives us definitely this vector actually. This one. This part will give us that vector. Because the vector, when we what is P? P is A plus this one. You get the vector OP, which is vector P from point O to point P. Okay, so we'll do some algebraic things. So it becomes like this, which is in terms of vectors and the ratio. So okay, maybe find the position vector of point P in terms of vector A, B, and its ratio. Right. So maybe this statement will make you clear that your answer won't to be any scalar value or any simple scalar with vector, for example, like 3a plus 2b, for example, like that. So in terms of, will give you a step forward healing that your answer might be quite miserable, and you know that, oh, how come my answer will be like this? So in terms of, will give you definitely the way to help the student understand your answer won't be as a simple one. All right, so that is straightforward. If you want to review, so refer to this lecture note. Alright, basis, vector, and component. So basis is asas, component, vector, and its component. It is quite widely used, quite frequently used in tensors. So it is the way to represent a new vector using the same basis. Okay, for example, So you have a three vector of E1, E2 and E3, which is this become a basis basically. When people talk about most of the example of tensors for vector analysis, they use E. Okay, three vectors E1, E2 and 3 are said to form a basis for three-dimensional space. It is a basis, asas. The scalars of A, A2, A1, A2 and A3 may be positive and negative. So that will be representative for the scalar value, the magnitude. For example, 3E1, meaning that for E1 basis, you have three multiplication or three times or three vector E. For example, this one, and then this one, and this one. So bases are the same, which is using E1, but you have three E1. So meaning that the basis will multiply with three times will give you one component vector for vector A. So E1, E2, E3, it can be, if you want to make it easy to understand, maybe you can say E1 is referred to I, what else? E2 refer to J, and so on. But this basis is not that one, because I, J, and K is normally refer to the axis coordinate, the axis of the system, coordinate system. Either you are going to use Cartesian X, Y, and Z, or something else. Right. So have a look here. We will explain more. So if we wish to label, so now this is what I'm talking about. If we want to label it using a Cartesian coordinate of X, Y, so it's become much more easier because you already involved this thing. You already learned this thing of I, J, and K for each component of X, Y, and Z. So which point along positive, blah, 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 and so on. So can be written AXI, AYJ, and AZK. The vector interdimensional require three components are fully direction and its magnitude. Okay, for example, displacement in space may be thought of the sum of displacement along X, Y, and Z direction. So, for example, you want to represent what is A. So A should be composed in I in X direction, Z for K direction, and Y for J direction. So A might be the composite of three directional basis. So for brevity, the component of vector respect to particular, it can be written as so this shouldn't be like this. Should be like this one. So because the vector writing scheme is using a bracket like this, a bra and cat. So this is the opening, this is the end up, the close one. So if you run, because normally when you write 1 0 0 0 1 0 without a bracket, this is basically referred to a point. So but if you using this one 0 1 0, this is referred to vector because it's written in the form of bracket system. Notation. So we can consider it. You must simplify. Differentiate between this and this bracket, this parenthesis. If I'm not mistaken, I forgot the name. Semicolon or parenthesis with this bracket. So this one is a multiplication of A plus B, doing first I, and so on. We consider the addition also. This is the way how to write. If you have a lot of vectors that involve in each component different scalar value, but within the same basis, tapak yang sama. So then you must cumulative it. Composekan dia dalam satu point, dalam satu it's not point, dalam satu group, in one group. Right, so SM goes as minus subtraction. So, for example, two particles have velocity of v1 and v2. Find the velocity u of the second particle relative to the first. So, two particle. This is the first one, and this is the second one. So the particle are moving in independent direction, but they have the same some sort of apa nama tu, some sort of same in same space, but different direction. Okay, so how do we do? I mean, we just minus a value, because value of v to find the velocity u of the second particle. So u2 respect to the first. So both are moving, but the velocity of the second particle respect. We don't have we cannot use v2 anymore, because v2 is given here. Either you are going to use u or whatever. In here, the example is using said u. You can say a v dot maybe for 2, which is a relative speed or relative velocity respect to the first particle. So it's given right here. So you must add up or join the same component. It is quite clear and easy and clear. So next is magnitude. So what is magnitude? Magnitude are the same. You have to do a square of each component and then square root. So that is the things that we are supposed to understand. What is the magnitude? Finding the magnitude, or we call it as magnitude square, modulus. Modulus. So modulus is square root, squared and square root. For instance, he speed the second particle relative to first given. Okay, so okay, all right. Sorry, I forgot to explain this one. Okay, so you have a vector. We have a vector of the second particle respect to the first one, but we know the vector, but we didn't know the value. I mean, macam mana kita tahu direction tapi kita tak tahu apakah nilai yang dibawa oleh partikel tersebut, kan? Let's say this one and this v2 somehow is somehow the vector we know that the second particle is travel faster than first particle, but we didn't know how do we describe what will be the value, what will be the value of that speed. We know the vector, but didn't know the speed. So we find that the speed, the skala, the value, nilai yang dia bawa tu in terms of skala value by using the magnitude, by using the magnitude of the vector ataupun modulus lah. So for this one, for example, you have a square root 73. Square root 73 normally will give you, wait a minute, I just need to use my calculator for a while. Square root of 73, 8.5. So 8.5 is a value. So macam dia kata partikel 1 dengan partikel 2. Partikel 2 lagi laju lah. Yes, definitely. That's correct, because we knew from the relative. So relatively V2 lagi laju. But when it comes into apa nama tu, when it comes into apa kita panggil easy notification, easy things to notify. You just said dia lagi laju, so how much dia lagi laju tu berapa banyak kan? So we get the magnitude, so then you know 8.5 much faster than V1 ataupun the first particle. So that is the magnitude lah. So magnitude equals to a unit vector. A unit vector usually noted as A hat which is A divided by the modulus of A, will give you a unit vector. Maksudnya, if we have A here, then we divide with its magnitude, so it becomes a unit vector. So this is A. So A is become a basis sebenarnya. Dia jadi asas. Sebab dia adalah satu vektor yang nilai di unit dia adalah 1. Dia adalah pecahan from part of that. So we have constantly multiply vector by scalar, multiply vector by another vector. So the scalar product of two vector is just a number, whereas a vector product itself is a vector. Kalau scalar product jadi number lah. So this is scalar product. So when you have two vector, tambah tolak becomes a vector. But when we product from vector A to B, so it becomes a scalar value. So this is scalar value, and it would be where theta, the angle between two vector, tail to tail or head to head, is okay, no problem. We must make sure both are. But if the A dot B doesn't have a value, that's mean the vector itself doesn't intersect. We cannot find. If we, for example, you have a parallel line of A and B, so your theta cannot equals to 0. Yeah, definitely it's more than 100. Is 180. Is enough. I mean, it cannot be calculated. We cannot determine what will be the theta between two vector. The projection of V to B cos theta. So this is the way to understand it. So A dot B equals to 0, meaning that perpendicular. So if A dot B is 90 degree, so then unless B either them is 0, meaning that B is 0, is A dot B equals to 0. So it cannot be used this term, this kind of explanation. So for example, I dot I equals to 1 because the angle is 0. I dot J is become 0 where the angle becomes 90 degree. Example of scalar product, work done and so on. So what else? 4 non-coplanar points and position as AD is perpendicular. Denote that for position ABCD as none of 3 pairs. Okay, so first, this is an example to understand. I mean, it's all about the theoretical definition or the falsafah, the philosophy behind this. We are going to learn until scalar product. So wait a minute. I need to stop here for a while. We will continue on the second part of the vector algebra on scalar product, vector product. So I will finish until the scalar product, and we will continue on the second part on next class for vector product. Okay, right. So let's go back to this slide. So for non-coplanar points of AB are positions such that a line AD is perpendicular to BC. So AD is perpendicular to BC, and BD is perpendicular to AC. BD is perpendicular to AC. Show that CD is perpendicular to AB. So for position, let's say we have a vector. So this is point. This is our point. But when we start from if we to make this kind of philosophical thought or analysis becomes easier to understand, we start to denote from A to 0 to A. So we call it as A, vector A. 0 to B is become B, and so on. So as none of the 3 pairs is actually intersect, so it is not intersect, it is difficult to indicate their orthogonality in the diagram, so we will normally draw. However, the orthogonality can be expressed in vector form, that we start by nothing, that since AD perpendicular to BC, so AD is perpendicular to BC. So what is AD? AD. Okay, so AB A dot B, line AD is perpendicular to B is DC. A dot B equals to 0. So what is A dot B equals to 0? So DA, this is A dot B equals to 0. D minus A, C minus B equals to 0. Combining two equation. Oh, so I think this one I need to draw it. I need to draw it because it's more it's much more on abstract things to explain. I need to draw it. I need to draw it to make you become easy to understand. It's okay. The work is given here. The way to solve it is given here, but I need to draw properly so then you can imagine and straightforward apply all these things. So I stop for today lecture. So we will continue after this. Thank you very much. Assalamualaikum.